So in this video, we're going to continue our basic network troubleshooting from the perspective of the small office, home office, by now going into basically step 11 in that flow chart. So previously, what have we covered? We've covered the assumption that you are the network administrator for at least one router, which is serving as the default gateway for all the employees who are having problems, having issues accessing their internet resources. We're assuming that nobody else is supposed to access this router. Only you have access to it. It's been quite a while since you've logged into this router and changed anything. It was working fine for several weeks, and all of a sudden something happened. And it wasn't you because you haven't been in this router for quite a while. We verified that you could get into the router. You're not locked out. All the interfaces look good. They're up. You actually do have routes to the internet, which is what you expected. So, and we also verified that you can ping the internet. In our very last step, we went onto the router, and from the router itself, we tried pinging the same internet resource, like a website, that the employee said they could not reach, but we verified that you could reach it. So now we're going to get to the next step, which is step 11, which is, okay, is that actual router advertising the employee subnets upstream? And if not, troubleshoot that. So what are we talking about there? Let's just do a brief recap to explain what that's dealing with. So let's say that this right here, this circle, represents a section of your company where some employees happen to live. And let's say that in this particular section here, let's just make it really small. We've got maybe 3 switches. And those 3 switches are connected to various employees, and they all feed into the exact same router. 3 different interfaces on that router. So maybe let's just say that the top switch, the people connected to that are in human resources. The middle switch, people connected to that are in payroll. And the bottom switch is engineering. And the issue is that the people in, let's say, payroll are saying that they've lost all of their internet connectivity. So this is the upstream interface, and let's just say this big circle here represents the internet, which, as we know, is really just a humongous collection of networks all interconnected together that are reachable via each other. Okay, well, we verified that there's some resource on the internet that we're testing. Clearly, we can't test access to all 500,000 routes in the internet. So we asked the people in payroll, specifically, what were you trying to get to? And maybe there's some payroll website. You're a small company, and so some of the resources that you have are hosted in the cloud, which means you've got some service provider, and maybe they've got a server, and they say, hey, you can use our server. So maybe we'll give you your payroll records are going to be on our server here in the cloud. And let's just say that's on the 9.9.1.1. That's the actual IP address of that server. So the people in payroll are complaining they can't get there. And they're supposed to be able to get to that via the web browser, Google Chrome or something, and bring up a nice GUI, and from that they can browse what's on that server with the payroll records, but they can't hit it. So we verified in the very last step that from the router itself, we actually could ping that IP address. And we talked about if I could not ping it, what are some of the things to look for? But at the end of the last video, we said, okay, that's done. We're finished. That is fixed now. So we know that from the router, we can ping 9911, which means that when this router initiates his ping, he is most likely going to use whatever IP address is right here on this interface as his source. That'll be the source IP of pings. And then, of course, this will be the destination, 9911 of the pings. And that works. So we know that at minimum, all the routers that connect our default gateway all the way until we get to this payroll server, which could be, hundreds of miles away, we don't know, is all those routers know how to get to this IP address, and all those routers know how to reply back to the IP address of the router. Our ping from the router has confirmed that. But the payroll department is still complaining they can't reach this IP address, this website. So now we have to ask ourselves, okay, what subnet, what network does the payroll department live in? Maybe there's a problem with that network. In other words, maybe the routers on the internet all leading to the server don't know about the payroll's network. They don't know how to reply back to the payroll's network. And that's what we're talking about here. I know you, but you don't know me. In other words, I know how to get to you. I know how to get to that payroll server, but it doesn't know how to reply back to me. So, step number one, identifying. What we're trying to identify here is my default gateway actually advertising the employee subnet? So in this particular case, in order for this to work end to end, then what that would mean is on the default gateway, this interface right here, which is going to be the exact same subnet as my payroll employees. It's going to have an IP address that's in the same network as the IP addresses on the laptops of my payroll people. Whatever this interface is right here, the network that sits on this interface, we need to verify, is this router actually advertising that network upstream with whatever routing protocol is being used. We don't know if this guy's using BGP or EIGRP or OSPF. Now, clearly, you as the network administrator would hopefully know what routing protocol is going on between your router and the next router up the chain. And whatever that routing protocol is, you have to wonder, okay, everything was working fine. All of a sudden it's not. So did someone get into my router? Did they hack into the router, somehow figure out what the username and password is, and do something so this router is no longer advertising this green network? Because if he's not advertising the green network, that would mean that people can't reply back to payroll. They can't reply back to the green network. So how do we see if he's actually advertising that? Well, we can use the show IP protocols command. And for every routing protocol you're running on your router, RIP, EIGRP, OSPF, they'll all show up as a high-level overview or snapshot in the output of show IP protocol. And part of that output will tell you what networks this routing protocol is routing for. In other words, the router will say, okay, of all the networks I'm directly connected to, these are the ones I'm advertising via this routing protocol. And we can check for that. We can also look at the database. For example, if the OSPF database or the EIGRP database. Now, if we're doing OSPF, you can do show IP OSPF database and look for self-originated LSAs. Remember, as an overview of OSPF, if we're running OSPF between this default gateway here, and let's just draw another router right here, the next one upstream, let's say that's router X as an example. So if there's OSPF between these two, and this network here is directly connected, we know that this router is going to create an LSA, a link state advertisement, describing this link and the network on this link. Now we'd have to look a little bit more detail about what type of topology this is and where the areas happen to sit. But it's going to be either a router LSA, a network LSA, or a summary LSA. It's going to be one of those three types of LSAs that's being advertised to router X via OSPF. And it's going to be self-originated. In other words, this router here is going to create that LSA himself and then forward it on. That's why we'd use the show IP OSPF database, select the correct type of LSA. You'd have to know your topology to answer that question, and then do self-originate and see, did he actually do that? If we're talking about EIGRP, and we sort of looked at this in the last video, look at your EIGRP topology and ask yourself, okay, in that output of the topology, do I see this green network? Is it listed as a passive network in my EIGRP topology? If it's not there at all, that means I'm not advertising it to my neighbors. If we're running BGP with our neighbor, show IP BGP neighbor and then whatever the IP address is of that neighbor, and then the keyword of advertised dash routes. Now I'll actually show you what routes did I advertise to that neighbor, and I'm looking for that payroll network. If all of that looks okay, whether you're using OSPF, EIGR, BGP, you see the network there. It looks pretty clear on your default gateway that, yeah, you're advertising that network. So not only should you have reachability to the internet, because you've got from the previous steps, you've verified that, but the internet should be able to get back to you because now you've verified that. At this point, you pretty much exhausted your reasons on the default gateway, and it's time to move to the upstream devices routing table. Now let's say you don't see some of these things. You say, oh, okay, here's the problem. The problem is, yeah, this router, he's not advertising the payroll network. That's why people in payroll aren't getting responses to their packets. Now the question is, why? It was working, 10, 15 minutes ago before people started screaming and calling me. Why is it not working now? Well, routers just don't on their own suddenly decide, oh, I don't want to advertise this network anymore. I don't like it, so I'm not going to tell you about it. They don't do that, right? If a router is advertising a network and all of a sudden stops advertising that network, well, we've already checked in a previous step that this interface was up. I mean, if this interface had gone down, well, that would be a legitimate reason why the router would say, hey, buddy, upstream, this network here I'm connected to, it's gone, doesn't exist anymore. But we already verified that's not the case. Back in like step 5 or 7 or something, we said, hey, downstream and upstream interfaces are up. So if the interface is up, why else might he not advertise this network when he was previously advertising the network? Well, the only really thing that might happen is somebody hacking into your router. If the interface is up and it previously was being advertised, the configuration was okay, something must have changed in the configuration. That would be the only reason why he would stop advertising that network. So what in the configuration are we going to be looking for? If someone hacked in there, what could they have possibly have done to cause that network to no longer be advertised? Well, they could have removed or changed a network statement, either an EIGRP or an OSPF or a BGP network statement. If that network was being redistributed, they may have removed the redistribute command or maybe modified it in some way that was kind of sneaky. They may have implemented an outbound distribute list. We talked about that in the previous video. That's a way of influencing your routing protocol and giving it permission to advertise certain things but not advertise others. Just like in the previous video, there could be some route maps that have been implemented or maybe changed a little bit. Or some prefix lists. These are all ways of manipulating routing protocols as far as what they are allowed to advertise and what they are not allowed to advertise. Now, someone also mentioned in the live chat, and this is actually a very valid point, Jared brings this up. He says, hey, maybe what happened is everything was working fine for the last 6 weeks because your configuration was fine, but you being a newbie or something, you forgot to save your configuration. And so the configuration that was working was an unsaved running config. And for some reason, the router rebooted. Maybe it lost power, or we saw in a previous video, a variety of reasons that could cause the router to reboot. And if that's the case, your unsaved changes are gone, and that could result in maybe one of those unsaved changes was the command to influence that network, and that command is now deleted, it's gone. Okay, so let's go ahead and troubleshoot this. So in my particular case, let's see what I can access and what I cannot access. So can I get to r2.com? Doesn't look like it. So I can't get to r2.com. Can I get to my other website, r4.com? No. Okay, so bring it back to my own topology here in the lab. Let's get rid of some of this extra stuff here. Okay, so employees are saying they cannot get to r2.com or r4.com. Now I know, and they tell me, okay, they've done their own troubleshooting. They filed a previous set of videos and they said, okay, did these resolve to IP addresses? Is DNS doing its job and resolving this? And let's say the answer was yes. So R2, let's just put this in here, resolve via DNS to 2.2.2.2, and this is resolved via DNS to 4.4.4.4. Okay. Now in the previous video, one of the things we said was, let's go to the default gateway and see if we can ping those addresses. So here I'm at the default gateway, ping 2222. Yep, I can ping that website. And so I can ping them both from the router. And so now here we are in this video. Okay, I've got access to it from the router, but the employee cannot get it from his. So now we say, okay, well, the subnet this employee lives on is the 111 network. Let's just put that right here. You know, the employee who's calling us up, I asked him to do an IP config, him or her, and that person told me. And I explained, you know, look for an IP address. And the employee said, okay, I'm 1113. That's what the employee is. Let's put that here. So the question is this default gateway advertising the 1110 network? Well, we said we could start out with show IP protocols. Let's get into that. Show IP protocols. And here we see this router is running EIGRP, and what we're looking for is this section, routing for networks. And at first glance, it might look okay, but if you just take a split second and really look at this, wait a second, 111.11? That's not right. It should be 111.0, not 111.11. So let's take a look at our config and go down to the EIGRP section. Okay, we have the correct subnet on this interface. That's right. And here's our problem. Somebody got into this router. They removed the previous network statement that was correct, and they replaced it with 111.11. The previous network statement that was working was network 111.111.000.255. So by adding the sneaky additional 1 here, that messed everything up. And so now we're not advertising. And if I do show IP EIGRP topology, notice the 1110 network, it's not in there. So now we have to go into our EIGRP configuration, get rid of that network statement that's incorrect, and now put it back in but modify it, get rid of that additional 1. Go back to our EIGRP topology table. Now we see this connected network is being advertised. We go back to the employee. Hey, could you check that website again? See if it's working for you? Okay, r4.com. Now we can get there. www.r2.com. And now we can get there. So the root cause of this issue was that something had happened in the default gateway. So the default gateway was no longer advertising the employee's subnet upstream. So upstream routers could not reply back to packets that were sourced from the employees.